Hi everybody, welcome to Mrs. Neller's notes for her pre-calculus class. And in this activity, I'm going to show you how you can use your graphing calculator to make a line of best fit for a trigonometric function. So on the right-hand side of your screen, you can see example 1, and we're going to model a situation here. So they give you a little bit of background information. They say we've got a certain narrow channel, and it talks about the water depth in that channel, and it varies with the tides. So you're familiar with that concept, high tide and low tide, and how much water there is at a certain amount of time during the day. And then it also says that table 1 shows the water depth over a 12-hour period. So you can see the table there, and it's got the different times listed, and it's also got the different depths of the water. Okay, so we're going to use that information to make a scatter plot. And a lot of times students will ask, where do these equations come from in our math book? Sometimes it feels like they're just pulled right out of the air, and we just substitute values in for the variables and we solve. Well, those equations first come from a set of data, and we have to graph them, okay? So we're going to do that first, and then in part B, we'll make our function or our equation that fits that model or that situation, that models that situation. And that's called our line of best fit, okay? And then for part C, we're going to actually answer a question about this situation. If a boat needs at least 11 feet of water to cross the channel, during which times can that be done safely, okay? So very first thing we're going to do is we're going to put the information in this table into our calculator. So to do that, you're going to go to the left-hand side of the screen now. You can see the graphing calculator. You can follow along. You can pause the video if you need to. You can go back and watch the steps again if need be. But we're going to click on the Stat button. And then we're going to just go to Edit, which is option 1 there. So you can either click option 1 or you can just hit Enter. And this will take you to your lists. Now, I put in just some fake information here because sometimes you have numbers in your lists and we need to clear those out. So I just wanted to show you the steps for how we do that. So just go to either one of the lists where there's numbers, arrow up so that either L2 or L1, list 1 or list 2 is highlighted, hit clear, and then hit the down arrow, and your calculator will automatically clear it for you. So I'll repeat that. You just go up, clear, and then down, and your list is clear, okay? So you may or may not have to do that. But the next thing you do have to do is you have to put the information from the table into list 1 and list 2. So the first column with the time is going to be our list 1. The column with the depth is going to be our list 2. Now there's one little trick with this when we're putting these numbers into our calculator. If you look at the time here, it starts at 12 a.m. and goes to 12 p.m. So students are tempted to put in just the hour that they see. So they'll put in 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But then you have 2 12s in there, okay? Now, the problem says that this is over a 12-hour period. So we really want to start at time 0 and then go for 12 hours. So for that 12 a.m., I'm not really going to put 12 into my calculator. I'm going to put 0 into my calculator, okay? And then I'll put 1 in because 1 a.m. is the first hour. And I'll put 2 in because 2 a.m. is the second hour, and so on and so on. So to enter the numbers into your list, you just type the number and you hit enter. And I'll try and go quick here. You can fast forward through the video if you need to. But just make sure you get both digits when you're doing 10, 11, and 12. Don't go so fast that you miss a 0 or a 1. Okay, and once you get those all entered, it says at the bottom here, I'm going to arrow up, it says L1 and then in parentheses 13. So it means that you have 13 numbers in your list. Okay, so that's nice that the calculator tells you that because after we put in our information for list 2, we want to make sure that we go from L2, 1, all the way down to 13. So that way you have the same number of items in your first list as you do in your second list. So for list 2 now, we're going to put in the depth of the water in the little channel. So we have to be careful here with our decimals. 11.4. So you can just read them right off the table. Just make sure that you're entering the correct ones. Don't go so fast or don't skip over any. Don't put any in twice. So this takes a little bit of time, but this is the most time that it's going to take us, is entering this information into our table. So I'm at 5.7, 5.4, we're almost there. Now when it says 6.0, you don't need to do the 0.0, you can just do 6. Same thing for 7, and then we've got 8.6. And then for the 10.0, you can just put 10, okay? So I'm going to arrow up again so that you can see now it says L2 13 equals 10. So we know that we've got the same number of items in both of our lists. So that's key. You want to make sure that our list 1 and list 2 have the same number of values, because basically this is going to be our X values and our Y values on our scatter plot, which is what we're going to do next. Now, before we can do our scatter plot, we have to make sure that the scatter plot is turned on. So I'm going to go to second Y equals, because up above that it says scatter plot. Now mine are all turned off, so I'm going to hit enter on the first one. And then there's the little blinking cursor over on, so I'm going to hit enter and turn it on, okay? The different types are here, so your calculator does all different kinds of graphs. We're just going to leave it on the first one for the scatter plot. The lists should default to L1 and L2. You saw that there were more than just 2 lists, so you could change these if you wanted to. The names for the lists are up above the 1, 2, 3, 4, 5, and 6 buttons, okay? And those are in blue. So if you did need to change one, you could arrow down, do second, and then whatever number you needed for that list. The mark, you can change that too, and the color you can change, but it's fine to leave that as the default settings, okay? Now to graph our scatter plot, we have to go to zoom, and then we have to do stat, which is option 9. So we have to do zoom 9. And there's your scatter plot. Okay, so we've already done step A. We have our scatter plot of our data. And we're talking about sine and cosine functions. So as you're looking at the scatter plot, I hope you recognize that this looks very much like a sine curve or a cosine curve, depending on how you want to interpret it. I'm going to interpret it as looking at a sine curve, because it does kind of start at the midpoint and then go up, and then back down, way down low, and then come back up to that midpoint. So I'm going to think that this is probably a sine function, okay? So that's going to be important later, because the calculator is going to generate an equation for us, and it'll either have sine or cosine in it, okay? So that's what we're going to do next. We're going to get that equation. And to do that, we're going to go to Stat, Calc, and then I'm going to arrow up because it's a little bit faster. And I'm going to go to option C. Now, depending on your type of calculator, it may not be C, but it needs to say sine reg, which means sine regression. Okay. You probably worked before with option 8 up at the top, which is linear regression. So that's y equals mx plus b format. You can see we've got all different kinds of ones. We've got exponents, powers, logistics, and then sine regression. So I'm going to choose enter for option C. And your newer calculators will take you to this screen. The iterations, we don't really have to worry about that. It has a default setting of 3, so that's fine. Make sure your X and Y, though, is set to list 1 and list 2, because that's the data that we put into our calculator for list 1 and list 2. You don't have to worry about the period or storing the regression equation. We do, though, have to arrow down to calculate and then hit enter. And your calculator spits out a bunch of information for you, okay? So this is our form for our equation. Since it's a sine function, this is our general form that we've been talking about in class. You can see the variables A, that's your amplitude or how tall the waves are. Then we've got sine, that's our trig function. We have the bx plus c, so that's going to shift it left and right. And then we've got the d value at the end that's going to shift it up and down. And then the calculator tells you the values for each of those as well. So you need to take a moment and you need to write this equation down. So pause the video and you can write down y equals, and then instead of a, put in the value for a, 3.09, okay? And then sine, and then you can substitute in the value for b, 0.52 or 53 if you want to round it. And then x plus C is going to be 0.54. And then plus D at the end is going to be 8.42. So you can just look at the first two decimal places there. You can round or not. Your answers might be slightly different depending on how you round. So just keep that in mind. But as long as we're all pretty close, we'll be fine. Okay, so once you have that equation written down, then we have to put that into our calculator and see if it fits our data. Now, for the line of best fit to fit the data, we have to have a line that is going to touch as many of the points in our scatter plot as possible. Okay, so if I go back to my graph for a moment, we want a line that's going to go through as many of these pink dots as it can. It's going to try and touch them as closely as it possibly can, like finding a pair of blue jeans and trying them on. You want to make sure that they fit in your waist, that they're not too long or too short, too baggy in the butt. So you want them to fit nicely. And we want that to happen for our equation here as well. So I'm going to go to y equals, and I'm going to type in that equation that we wrote down. So that was 3.09. And then you have to do the sine function. And then the parentheses automatically pop up. You can type in the 0.52. You can put the 0 in front of the 0.52, or you can just do 0.52. Remember the X is the X button plus 0.54. And then you need to close your parentheses and then add the 8.42. So that was the equation that we got from the calculator. Now, when you're doing this, I'm going to go to the mode menu, just as a reminder that we should be in radian mode here, since we're dealing with our trigonometric functions. Okay. And now when I hit graph, there's my line of best fit. And you can see that it gets really, really close to every single pink box that there was. Some of them, the line goes through the box. Some of them, the line just barely touches it. But that's the equation that hits as many of them as best as it can. So that's our equation for our line of best fit. So that's part B in our example. Find a function that models this situation, the water depth with respect to time. Okay, so we've done that. Now we have to take a look at part C. So we've entered our data, we have our equation, now we get to do something with it. So it says, if a boat needs at least 11 feet of water to cross the channel, during which times can it safely do so? Okay, so we're going to use our calculators to do this too. Now we could look at our table of values, but that's not really going to be helpful. You can see that at hour 0, we've got 10. At hour 1, we've got 11.1. So somewhere in between there was 11.0. And here between hour 3 and hour 4, again, somewhere in between there is 11.0. So I want to know those exact times, okay? Even if we look at our table on example 1, you can see that at hour 0 to 1 a.m., somewhere in between there, that's where the 11 feet of water is. Same thing for between 3 a.m. and 4 a.m. It goes from 11.2 to 9.6. So somewhere in between there is 11.0. We want to find 11.0 exactly, okay? So I'm going to show you the trick for doing that. We're going to go back to y equals, and you can arrow down so you're at the second equation, and just type in 11. And then when you hit graph, that'll make a horizontal line go across your graph. And now we have 2 points of intersection where the exact time will be when the height of the water is 11 feet, or the depth of the water is 11 feet, okay? So now we're going to review something that we've been doing all semester, is how to find the point of intersection, okay? So we're going to go to second, calc, and we're going to do option 5. And remember, when it says first curve, you want to have your cursor on one of the equations. My colors here are blue and red. Yours might be a little different. You might have to arrow the cursor around, but I'm going to put it on the blue line. So the blue equation will be my first equation. And it needs to be close to where that first intersection is. Then hit enter. Now when you hit enter, the cursor automatically jumps to the red equation. So hit enter, and then it says guess. So when it says guess, you can just hit enter again, or sometimes you can arrow the cursor so it's close to where you think that intersection is. It doesn't really matter if you arrow it over or not. When you hit enter, right at the bottom of your screen, it will tell you the exact X value for 11. Okay, 11 is the depth of the water, so this X value is our time, 0.86 hours. Okay, so write that down, 0.86, because we'll calculate that to a time in just one moment. But I've got to find my other intersection. So I'm going to hit clear, and then I'm going to repeat the process. I'm going to do second calc, option 5, and this time I'm going to arrow over on the blue line so it's closer to that other point of intersection where the two lines cross. Hit enter. It automatically goes to the red line. Hit enter. And when it says guess, you can scooch the cursor over a little closer to the intersection, then hit enter again. And there you go. At the bottom of the screen, it says X equals 3.10. So again, write that value down because that's your second time when the depth of the water is 11 feet. Okay. Now, X is our time, remember. So this means 3 hours and 0.1029771 of the next hour. Okay, so we know it's 3 hours, but we're going to change this decimal into minutes. Okay, so this is another refresher for you to make our answer make a little bit more sense. Okay, we can still use our calculator. Our first answer was 0.86. So that means 0 hours and then 0.86 of the next hour. So I'm going to take 0.86 and I'm going to multiply it by how many minutes are in an hour. There's 60 minutes in an hour. Okay, so that's 51.6. So you could interpret that as 51 minutes, 51 and a half minutes, 52 minutes. I'm just going to say 51 minutes. Okay. So then that means our time would be 12 a.m. and then 51 minutes past that. So it would be 12:51 a.m. Okay, so that's the first time when the boat will be able to start traveling across this narrow channel because it would have 11 feet of water. And if you wanted to be super safe about your boat, you could probably round that up to 52 minutes. So that way you know for sure it's exactly 11 feet or more. Okay, so that's how we can interpret that data. Now the other answer was 3.10. So we know that's 3 hours. So that's going to get us to 3 a.m. And then we need to change that 0.1 or 0.10 into minutes. So I'm going to multiply that by 60 because there's 60 minutes in an hour. So that's 6 minutes. So then 3:06 a.m. would be the other time. Okay. So between those two times, between 12:52 a.m. and 3:06 a.m. is when this boat can safely travel across the channel. Okay. So that takes care of all 3 parts of this example. And hopefully that was a good reminder and a good refresher of how you can use your graphing calculator to find an equation of best fit to fit your data, and then to use it to help you actually solve a question about that data and the line of best fit for it. And as always, remember, if you have any questions, let me know.